Hi, I'm Joey D'Antoni. I'm Principal Cloud Architect at DesignMind and a Microsoft Data Platform MVP. And we're going to walk through using OpenAI and Azure Language Services with Azure Database for PostgreSQL. This is a pretty easy demo, and it's going to show you just how simple it is to build structures in your database that support AI tooling like vector embedding and sentiment analysis. And this will allow you to quickly and easily build pretty advanced AI applications that you can deploy into Azure to support your organization's AI goals. Let's go ahead and get started. If you want to follow along at home, you'll need an Azure account with OpenAI enabled. That's an Azure subscription. You may need to request OpenAI support. I did when I initially built this, but I don't know that you do now. To limit the amount of downtime in this video, I've already created my Azure resources, which you can see in my resource group. I have an Azure database for PostgreSQL, an Azure OpenAI account, as well as a Language Cognitive Services account in my resource group. We're going to take a look at the Azure OpenAI account, and after clicking on deployments, we can now see our deployments. It's important to note, and we'll talk more about this later, you need to note the exact name of the deployment you want to use. Here you'll notice I have one called embedding. That's an ADA deployment. That's the one we're going to use later, but exact names matter there. We'll also check our Cognitive Services language account here. We don't need to really configure anything, but we're going to click on keys and endpoints. We're going to do the same thing for OpenAI, is we'll use these settings to link to our Postgres database that we're going to use later in the demo. Finally, here for our prereqs, we're going to navigate to our Postgres flexible server. We're going to create a new database called rentals for this demo. You can create a new database in numerous ways. I just happen to be using the portal here. Typically, I might use pgadmin, and we'll show that later in the video. We're also going to navigate to server parameters. This has already been configured on this server, but you'll want to navigate to the second page of this and select Azure.extensions and ensure that Vector and Azure AI extensions are enabled for your server. This is a server-wide setting, and then you'll click Save. You might have noticed that I had a couple of other extensions checked. Those are for another demo I was working on and aren't needed here. All of our prereqs are now done, so we can now go over to pgadmin. This is running on my local machine. And we can see our database here by clicking refresh on the database hives, and there we see rentals. And if you're not familiar with pgadmin, it's a popular open source tool. It runs cross-platform, kind of like SSMS or ADS. I have all of my commands saved in one SQL script, so I'll right-click on my new database and select Query Tool. This tool is similar to other query tools you've used and will just allow us to interactively run queries or scripts. The first line of my script here that's commented out is actually a command line script to clone the GitHub repo. I'll put a link to that in the video notes. The code here will give you all the scripts to create the Azure resources you need using Bicep, in addition to the SQL scripts that we're going to show in this demo. You'll need the Git command line tools installed to clone this repository. We're also going to create a couple of tables here in our rentals database. Nothing exotic. These are just normal create table statements with normal data types. Then we're going to use the Postgres copy command to insert data into those tables. You should note that you can't run those copies from the query tool. You'll need to drop into the pgsql tool as I'm showing here. This is the command line interface to Postgres, and you'll notice I'm also changing the path of these to match where these files live in my operating system. Once we are there, we can run those scripts and see that we've created 50 rows and then 354 rows in the listings and rentals tables respectively. I'll switch back to the query tool and I'm going to run the show command to show what extensions are available to our Postgres database as part of the server extensions we enabled earlier. You can see those here. Now I'm going to create the extension for OpenAI in the database. For Azure AI rather, you should note that you're going to need to do this in every database where you want to use the AI extensions. After that, you're going to set the credentials using the Azure AI set setting function in your database. You're going to do this twice, both for OpenAI and the language service you created. And hackers, I've already rotated these keys, so don't bother trying. But these settings and the extension are all we need to get started using the AI tools in our database. Let's talk a little bit about vectors. Vector similarity is a method that's used to measure how similar two items are by representing them as vectors, which are a set of floating point numbers. Vectors are often used to represent data points, where each element of the vector represents a feature or attribute of the data point. Vector similarity is commonly calculated using distance metrics like Euclidean distance or cosine similarity. Euclidean distance measures the straight line distance between two vectors in the n-dimensional space, while cosine similarity measures the cosine of the angle between two vectors. The values of these similarity metrics typically range between 0 and 1, with higher values indicating greater similarities between the vectors. Some applications that use this vector data include recommendation systems, text classification, image recognition, and k-means clustering. For example, in recommendation systems, vector similarity can be used to identify similar items based on the user's preferences. In text classification, that similarity can be used to determine how similar two documents or sentences are based on their vector representations. To run this query, we're using the create embeddings component of this function, and it's important to note that the first literal we're passing in here is that exact name of the OpenAI deployment we created earlier. We're going to go back to it just to show it to you. In this case, it's embedding, singular and lowercase. When we execute this query, we can now see the vectorized values for our description column in our database. Additionally, if we wanted to, we could create indexes on that vector data. There's a specific vector type of index. We can use additional functions like cosine or L2, which is Euclidean distance, as well as aggregate our vector data. Last, we're going to use language services to do sentiment analysis across a couple of records in our reviews table. As you can see here, language services will produce a sentiment analysis and score based on its confidence in that score. It's a method that has 3 overloads, which allows you to either analyze the sentiment of one record or multiple records at a time by passing in an array of values to evaluate. There's also a language parameter, which you can indicate which of the 94 supported languages the input text is written. And the function's also going to assign a label, as you can see here, positive, negative, or neutral, to individual sentences or entire documents. These labels are going to indicate the tone expressed in the text and a return confidence score with the labels, which is going to represent the model's confidence in its predictions. Some of the places you might use this are if you want to understand customer feedback, monitor brand reputation, or personalize user experiences like adapting content based on sentiment. I hope you enjoyed this video and can get started with using Azure AI database for PostgreSQL. I'm Joey D'Antoni, and have a good day.